Hey everyone, Natasha here. Today I'm going to show you how to conduct an ANCOVA using a Type III sum to square approach for an unbalanced design in R. All right, so let's get started. All right, so if you haven't already navigated to my GitHub, please go ahead and meet me there at NK Pisano, and then look for the ANCOVA Type 3 Sums of Square example. Once you are on this repository page, go ahead and click that green button that says Code. When you do so, a drop-down menu will fall. Go ahead and select Download Zip. And this might take a while just depending on what you all have open or how many things that you've downloaded recently. All right, so mine's ready to go. I'm going to then move that Ancova file that I've just downloaded from my GitHub onto my desktop for simplicity purposes. Just makes everything just move a little more smoothly. Next, I'm going to pop open RStudio. All right. And then from there, once RStudio is open, I'm going to go ahead and navigate to that very top bar. And I'm going to select File. A drop-down menu will fall. And then I'm going to select New Project. And then a new window will populate. Go ahead and select New Directory. After that, you're going to be directed to select New Project. And then create new project window will open up. There are two things that we need to do here. Well, actually, three things, but I need you all first to create a directory name in Cova. And then we need to change where this project is going to be saved. So we are going to change that subdirectory. So let me move this project onto my desktop into the folder that I have downloaded from my GitHub. Perfect. And I'm going to go ahead and select open. And then I'm going to then select open in new session. So we did three things. One more time. We named our new directory because we have a new project going. We moved our project or set our project to open in the Ancova GitHub folder. And now we're selecting open in a new session. We want our project to open in a new session. Please then click create project. Give R a hot second. I have a lot of projects open right now that I just don't want to close. All right, I am going to do a couple of things first. I'm going to expand my window here. So let me do that, my new Ancova project. And then from here, I'm going to create a new script file. So please navigate to that top bar, select File, and then a drop-down menu will fall. Please then select New File. Another drop-down menu will fall. And then please go ahead and select either Quarto document or R Markdown. I'm going to be using R Markdown just for this demonstration. And then I'm going to give my new R Markdown a title. I'm going to title it Ancova. And then your name will be generated along with today's date. And then you can either render or create some sort of deliverable that is going to be an HTML file or a Word document. Highly recommend that if you're submitting something to someone, you can also use a PDF, which is something that I have all set up. And then I am just going to, for the sake of the purpose of this project, I'm just going to do Word and then go ahead and select OK. Great. And so then from there, please go ahead and download anything starting from a line 8 all the way down through 31. Perfect. And now I need to go ahead and save this new RMD file that I have here by going back up to that main bar, selecting file, that drop down menu will fall, then navigating back down to save as. Great. Now I'm going to, in this Ancova directory project, I'm going to name my RMD file Ancova and then type 3. And this will all make sense soon. And then save. Awesome. So one more time, we created a new R project. It has its own working directory. It has its own folder where everything is going to be hubbed. And so here it is. All right. So let's continue. Now, we need to open that HTML file that was in the ANCOVA downloaded file. So go ahead and open it. And then when you do, you'll see an HTML file. Click that. All right, and then we are going to split screen in between this ANCOVA HTML file and RStudio. Perfect. And this will help us just be able to get through the code while we're also implementing that code in our RMD file. All right, so let me tell you a little bit more about ANCOVA here. It is the analysis of covariance. I want you to think about this approach as another extension or a sister method of ANOVA. And as you have seen in my previous videos recently, that there are a lot of extensions to ANOVA. We're still going to be getting main effects, and we can still evaluate interactions of independent variables on DVs. In this case, what is so unique about ANCOVA is that we actually can control for covariates that we believe have sort of impact or known impact on our dependent variable. One more time, we are going to be controlling for variables that we think have some sort of impact on our DV and then assess the effect of independent variables and their interactions. And so for today's example here, it was inspired by Tabachnik and Fidel's example in their fabulous multivariate statistics book that I actually have and have used for so long. Highly recommend it. Comes with checklists, write-up examples. You cannot find another better book out there. And so in this example, we're going to be exploring the relationship between a woman's employment status and their religious affiliation and how that relates towards their reported attitudes towards drug prescription use, all while controlling for their current physical, mental health, along with any or the number of prescribed prescriptions. And so we can see how ANCOVA can be used for a non-experimental research design, but I hope you also know that this approach is often used for experimental study, evaluations, or analyses. For instance, take if we have an experiment where we have a pre, a mid, and a post collection of our dependent variable, and we want to go ahead and control for that baseline to see if there's some sort of effect of a treatment on the dependent variable. What we can do is that we can control for that time one period in using an ANCOVA. Another thing that we can do with ANCOVA is use it right next to a MANOVA where we have multiple DVs. In this case, we would use one of those DVs as a covariate to see the true effect of an independent variable on one dependent variable. All right, so it has its uses and it is beneficial for multiple experimental designs or research designs. Now, let me tell you a little bit more about the research questions and hypotheses that we can use when focusing on an ANCOVA type of technique. We can address a question such as, are there differences among women on attitudes towards prescription drugs who subscribe to different religious affiliations and report different statuses of employment while controlling for their mental well-being, physical health, and the number of current prescribed medications? We can take a look at their interactions, and a null would suggest that after controlling for some sort of number of covariates, the independent variables interaction in their effect are not related to some sort of outcome. In our example, we would kind of suggest that after accounting for mental well-being, physical health, prescription use, religious affiliation, and employment status do not jointly affect a woman's attitudes towards drug use. Okay. The alternative would suggest that there is an interaction. We can also take a look at main effects, but one more time, the one thing that is new and different here is that we state that we control for some sort of covariates before analyzing the effect of our independent variable on the dependent variable. So, for instance, in our example, we could say something like after accounting for mental health, well being, physical health, prescription use, women's different religious affiliations are not related to the reported attitudes towards drugs. This would be our null, while our alternative would suggest that after accounting for mental well being, physical health, prescription use, women's different affiliations, religious affiliations, were related to the reported attitudes towards drugs, suggesting that the means are not the same across women's who subscribe to a different religious affiliation on their attitudes towards drugs. All right. And the assumptions here that we have listed are very similar, if not exact, to ANOVA. All right. We're still very much interested in making sure that we have equal group sizes and that we have addressed missingness. We still do the same thing where we go ahead and evaluate residuals for normality, suggesting that the sampling distribution of means within each group are normally distributed, right? And it really isn't to deal with raw score distributions. But one more time, we are really concerned with our residuals here. That's how we can go ahead and make sure that our means are normally distributed across these groups. And so to evaluate that assumption there, we can use plots or we can use Shapiro's Wilks test to evaluate the distribution of residuals. We are also, this is something new that we are going to be concerned about the linear relationship between covariates and an outcome. So that means for every covariate, you should be plotting against the outcome. All right. And so outliers we have seen before, we know about them, right? We don't want extreme values to have some sort of influence on our on our outcome here, on our results. And so we need to go ahead and deal and manage those as best as possible. For us, we are going to be looking at plot residuals and to determine which observations are most influential using Cook's distance, which we have done before in previous videos, but I will be reviewing it here. And then we need to consider multicollinearity and singularity. We want to make sure that our covariates are not redundant, meaning that they're not highly related to one another. If they are, then what's the point of putting them into the analyses? At that point in time, you should be removing one. All right, and then the homogeneity of variance. I want you all to know that we have done this before. We're taking a look at the variance of the residuals and that we want them to be similar across groups, okay? We want them to be similar across groups. And so unique to ANCOVA, the covariances should be evaluated for homogeneity of variance also. You can do this by using a Levene's test. And so this would go ahead and this would test whether the variances of residuals are similar across groups. We want to test and make sure that test comes out not significant. Okay. And another thing that is new and is very, very highly important is the homogeneity of regression slopes. This is the one that I'm most concerned about. So this particular assumption states that the slopes of the regression between the dependent variable and the covariate across groups is the same. In other words, that the slopes are equal for all groups, right? And we need to estimate a model that includes the interaction between independent variables and the covariate. And if there is a significant interaction, the relationship between the covariate and the dependent variable is different across different levels of the independent variable. All right. So let's get into this. The first thing that I need you all to do is I need you to load some packages into your RMD file or into your RStudio rather. And so what you could do is that you could write out or select to employ a new uh, R code chunk. And you can do this by using Option Command I on your Mac keyboard. Right. And then please type out always notes on why you're using what you are using here. In this case, I'm using the reader library, the car, and the e-means library. And so you can go ahead and note that that you're using packages to run on ANCOVA. And so you can either type out library and then library will automatically generate. All you have to do is hit return and then type out reader to read in that data. And then you could also then on the next line 11 for me, type out library and it'll automatically generate, type out car and then command return to run that, or you can use the plus symbol. Then on line 12, go ahead and type out library and then it'll automatically generate, hit return. And in those parentheses, type out em means, and then go ahead and hit command return. And so now you have all of these packages loaded. If you do not have them installed, which is a little bit different, go into your console there and type out install dot, and then you can see that a function comes up, an argument or a function comes up, and then you can go ahead and hit return, and it'll automatically generate in those parentheses there, type out comma, and then you want to type out the package that you want to read. So for instance, if I didn't have the reader package, I would type in reader and then I would go ahead and I would run it. You don't want this install.packages in your actual R code chunk there because whenever you go ahead to knit it or to save it, it's running over and over again, and you just don't want that. All right, I have those packages already loaded. I don't need them, and so I can call on them just using the library function. Okay. All right. Another thing that I like to remind you all folks is that to stay organized, I recommend that you end up adding headers. So I'm going to add a header here and it's going to be on line 8. I've made myself some space. I'm going to type out a pound symbol. So shift three, and then I'm going to do this twice because this is going to be a second level, I believe. And then I'm going to type out packages. And so I really love how I can organize in R. If I go ahead and select that outline little button there, you can see that now I have some sort of header that is being represented within that outline. And you can actually use this as a point and click to navigate throughout your RMD files, which is fabulous when you have a very large RMD file with lots of R code. Highly recommend that you stay organized that for reproducibility purposes. All right, so I'm going to do the same thing here, two hashtags there, and then I'm going to type out read in data as my next header here. And so I am going to then read in my data that I have already placed within my R project here. And so we are going to read in that data now by implementing a new R code chunk. So Option Command I, that new R code chunk will pop up there. You can type out read underscore CSV, and then you can in those parentheses add quotes and then type out the name of that file there. So I think it's att underscore drug with the capital D dot CSV. And then you can assign this complete function here to an object that is going to be stored in your R environment. And so I am going to go ahead and use the equal symbol, or if you like to, you can go ahead and use the assignment symbol. That's Option on your keyboard dash, and you get that assignment function or that assignment key there. And so I'm just going to type out att underscore drug. Okay. All right. So that's just one way that you can read in data. Another way that you can go ahead and read in data is in that uh, file tab in the fourth panel. You can select attdrug.csv. And by selecting that, a drop-down menu will fall. You can then import by selecting import dataset. And then a new window will come up. You can go ahead and take a look at the data this way, browse around, and then hit import. You should copy this code and then place it into your R code chunk in your RMD file. All right. So there are so many ways to do the same thing, and that's all I'm trying to teach you here again. All right, nice. And so I love to look at my data before I move on and to really understand if there's any type of missingness. This is just a great way to do something really quickly, evaluate or explore the data before moving into the data. And I can see my setup here is correct. I want to make sure that every single independent variable has in this case its own level and it has religious affiliation and I have employment status, whether women were employed or not employed. Great. I know that that's the correct setup. And then I also have my covariates here, physical health, mental health, and the number of prescriptions, along with that dependent variable, attention to drugs. All right. Now, now that I have my data read in and I know it is by looking at my environment or the first panel there, I can then move on. We are going to be evaluating the data, evaluating the data, and we're going to do this in several ways. I wrote out another header there, also using those pound symbols or those hashtag symbols, whichever one you prefer. Go ahead, type out Option Command I to generate that new R code chunk. Option Command I. Leave yourself a note by hitting Shift and then the number 3, which would give you a pound, and then type out that you are going to be looking at raw values of IVs. Okay. And how you're going to be looking at these raw values of those IVs, not the covariates, but of the IVs, is by typing out table. It's a base R function. So table, you will see it automatically generate, and then you can hit return. Two parentheses will generate. Go ahead in that space. You can go ahead and type out, for instance, ATT underscore drug. There we go. And then we can then ask for specifically to look at religious status by typing out a $sign and then selecting religious status. And you can run this by typing out command return on your keyboard, and then you get the number of individuals who subscribe or adhere to a certain religion. And so the first thing that is popping up, and this is why I always evaluate my data, is that I am noticing that there are different number of women per each one of these groups here. Okay, which is technically uh, not a problem, but something that you need to deal with and address when you are running an ANCOVA. And I will show you how to do that very shortly. All right, on line 31, I also want to maybe take a look at some proportions. I just want to give you this tool in the back of your hand or in your pocket rather. And so please, starting on line, whatever you're on, go ahead and create an R code chunk. Option Command I for my Mac users, type out prop for proportion, and then you're going to see prop.table generate. This is a base R function. Go ahead and hit return, and then parentheses will come up. And then go ahead and type out table again, please. and you will see that that will come up in base R again. So go ahead and hit return. Then another set of parentheses will come up, and then type out the name of your data set there, ATT underscore drug. And then we're going to ask specifically for religious status by typing that dollar sign. So shift and then dollar sign, which is for, and then look at religious affiliation. And let's grab this together real quick. All right, and there are those proportions. I'm going to write out my note here. Looking. Always leave yourself notes because if someone comes into your RMD file, you want them to know exactly what you have done. Now, you should do the same things that we have just done for religious status to employment status here. And so, what I've done for you all is if you want to go ahead and copy my code, you can by hitting the copy code button there. And then all you have to do is just paste it into a new R code chunk, Option Command I, and then go ahead and paste. The one thing I am going to tell you to do is to change the file name here. Mine is name ATT underscore drug. If you want to go ahead and rename your data file there to DF, you're more than welcome to. That may cut out some time of always changing that first data set name or that data frame name. All right, and then you can go ahead and run these and you can take a look at the distribution or the sample size for employment status there. It's very, very similar versus when we look at religious affiliation, they are pretty different. Okay. And so then one more time, I'm just going to use my copy and paste uh, button there. And then I'm going to create a new R code chunk in my own RMD file. I'm going to go ahead and then paste that code. And then I'm going to change my name here just because I went ahead and I changed it. All right. And so I am now getting the proportion. You can see one more time, they are very similar. And this is what we want to see. All right. And so I really love this next line of code. I ended up getting from Daniel Navarro's book down. I think it's fabulous. So the aggregate function is fabulous for ANCOVA when looking at the means across these different levels of both independent variables. And so on line 48, I'm going to start a new R code chunk. Option Command I. And then I'm going to type out aggregate. Okay. Oop. Sorry about that, folks. And then we are going to, after we type out that function, we are going to state that we want to go ahead and analyze and look at differences in attitudes towards drugs there. And we want mean differences. So I'm going to also make sure that I'm regressing my religious status there. So relig underscore stat. And I'm also going to be adding my employment status variable stat. And then after I go ahead and I add those two variables, I can go ahead and hit comma and then list out my data frame name. In this case, it's ATT underscore drug. And then comma, and I want the means. So I'm going to type out mean. Okay. And so now I'm just going to write myself a note real quick. All right. And I'm going to run this line of code, command return. I just need to make sure that this is right. All right, there we go. And so then you can see here, I have a table. It has three columns, one where religious status, along with the levels of religious status and employment status, are listed in the next column, and then the means of attitudes towards drugs for each one of those level interacted with one another. Okay. Once again, I do all of this in advance to kind of get an understanding of what is actually happening within the data without running any type of analytic approach. And I think it's almost a tall tale sign of what we can be expecting in the future. Always going back to those means, super important. Always going back to the basics will kind of give you insight to what you can be expecting in the future for those future analysis. All right. So I one more time want to highlight that these proportions for women's different subscribed religious affiliations, right? The proportions are different and the raw values are different. And when they are very different, we need to do something about that. And we need to actually take a certain analytic approach to do that. So I'm just going to be briefly reviewing uh, something also known as sums of squared types. And it basically suggests that there is an ANOVA and there's a different way to do all these ANOVAs in general. And one more time, ANCOVA is a sister method of ANOVA. So that means that ANCOVA can be done in a different perspective or a different way. It's a different way of generating our hypotheses technically. And so we are so used of the default of a type one sums of square approach when using an ANOVA. And so what this approach does, sum of squares type one, is that it ends up kind of engaging in a sequential sums of square where we start with the most simplest model, which is one term, and then we continue to build and we continue to add term after term one at a time. So, for instance, let's just say we first would model an intercept model, and then from there we would then look at the relationship between attitudes towards drugs and the religious affiliation, and then in the next step we would add the second term where we're looking at employment status and drug perceptions or attitudes, and then at the very last step we would then take the interaction between those two variables and include them within the model and trying to see if there's an interaction related to our dependent variable here. In this perspective, in this case, in this approach, order actually matters. Order matters. And the way that we end up first putting, for instance, our drug affiliation or rather, our our religious affiliation into the model itself. Okay. And then we ended up putting in employment. We know for a fact that for us, it doesn't matter. Okay. But when we use type one sums of square approach, we're actually is saying that order does matter. And so then that kind of brings me down to a type three sums of square approach, where we run a full model. All terms are present. This is known as the alternative model. Okay. So we start off running a full model with everything in it. And then what we do is that we run a simpler model. This is also known as the null model. And we do this or we formulate this null model by deleting the term that we want to actually test. So we compare the full alternative model to the simpler null model. We adjust, right? We're adjusting each effect for all other effects. In this case, the only thing that actually matters are contrasts, right? You have to use contrast for this approach, right? The ons and off of evaluating how or when an independent variable is impacting a dependent variable. So this is kind of the disadvantage of using a type 3, but however, it is a little better in the sense that we don't assume that order matters in this case. And so then there is the type 2 sums a square approach. This is very similar to type 1, where we estimate a full model and we test a particular term by deleting it from the model. And so you cannot omit a lower order term when estimating higher order terms. In this case, for instance, let's just say that we were interested in looking at the effect of an interaction and we noticed that the main effects weren't significant, you still have to have that main effect in the model. Okay. In this case, type 2 sums of squares, order does not matter. And we do not depend on contrast. Folks often recommend, or methodologists often recommend, that we use a type 2 sums of square approach when dealing with an ANCOVA, when dealing with unequal sample sizes across those different levels of an independent variable. Okay. And so for this case, for R and COVA, we are going to be using a type 3 approach where we're going to be relying on contrast here. Okay. And I'm going to show you how we are going to do that. But before we even get there, it is our responsibility to actually understand if whether we have met assumptions. Okay, we need to know whether we have met assumptions. And the first thing that we are going to be doing is running ANCOVA. And so I'm going to first, in my RMD file, I'm going to give myself a header, and I'm just going to make this header note ANCOVA and the evaluation of assumptions. Now, to evaluate our assumptions here, what we're going to do is that we're first going to run an ANCOVA model. So I'm going to create a new R code chunk by using Option Command I on my keyboard there. And then I'm using the LM function because we're still technically looking at a relationship between an independent variable and a dependent variable here. And so I am going to type out LM followed by parentheses, and then I'm going to type out the name of my dependent variable, which I believe is ATT underscore DRG. And I want that to be related to my religious status by using that tilde first and then typing out religious status variable name plus the employment status variable label or name. Okay, make sure I get this right. You can also use the paste clipboard if you would like to just paste this all into one, but I want you all to get in the habit of typing things out. It's really important not to just use a copy and paste, especially since it's so easy to do it now. You should know what the code means and what it is doing. So physical health here, phi underscore health, and then plus. I'm going to also add my mental well-being variable plus the number of prescriptions. So you can see that this model technically includes my covariates also. And then after I'm done listing all my covariates, I'm going to type out data equals, and then I'm going to type out the name of that data frame there, ATT underscore DRUG for drug. All right, and then I'm going to be assigning this to a name so it can be stored within my environment by typing out equals right in front of LM, starting on line 56 on my end. So I'm going to name this ANCOVA model underscore mod. Cool. You can run this either by going to the line there and then hitting Command Return, or you can go ahead and hit that play button. All right. And then I'm going to create some space. I'm giving myself a line there, line 58, and I'm going to type out summary and then return. And then in that parenthesis there, I'm going to type out ANCOVA underscore mod for model. And then I'm going to then run that. All right. And there it is. Make sure you type out yourself a note. So using LM, a linear model function to quickly look at the ANCOVA residuals. That's what we're going to be using this for. All right. So great. We have a model. It's been estimated. And now we can go ahead and kind of get a sense for the goodness of fit of this model. How well is our data fitting the model that we went ahead and we implemented here? We're going to be using the plot function. I love this function. So plot, and then you can go ahead and hit return. It is in the graphics library there. So I'm going to type out return, and then I'm going to type out the name of my model there. So it was ANCOVA underscore mod, and you can see it automatically generates. So I'm just going to hit Command Return to generate those plots there. I'm going to leave myself a quick little message here. I am going to type out looking at residuals, because that's what these plots are going to give me. They're going to give me residuals plotted against certain types of information. So let's go through these one by one. So in my first plot here, what I have is I have my residuals plotted against my fitted values. My residuals plotted against my fitted values. And you can evaluate this plot looking for a type of pattern. You want all of your actual observed scores or actual residuals, sorry, plotted around the zero, around that zero mark. And you can see that R has given us a dashed line there. And so we want all of our residuals to be around zero. We don't want there to be any type of pattern that suggests that there's some sort of like, I don't know, like curvilinear relationship or anything like that. Because in this case, if we have our zeros sprawled across all fitted values and are centered around zero, it suggests that there is some sort of linearity and that technically we have met the assumption of homoscedasticity. Okay, so one more time. If our residuals are dispersed across the fitted values here, across X, right? They're all the way across that line, and they hover, right? These residuals hover around zero. Then we can go ahead and suggest that linearity and homoscedasticity have been met in this sense, okay? We're going to have to further evaluate linearity and homoscedasticity, but this is just giving us an overall taste of what is happening, right? One more time, we don't want a curve pattern. We don't want any pattern besides just randomness. All right. And so then for our next graph here, we have the QQ plot. And so we can use the normal QQ plot to evaluate the normality of our residuals in an ANCOVA. And so we want all of these residuals to be plotted against that normal line, suggesting that the residuals are normally distributed. If we had the most perfect model, the most perfect model is that line. And this is why we want our residuals to follow that line so well. Okay. Next, we have a third plot that can help us out here. I've shown you all these before. This is one more time a plot that can help us determine whether we have met homoscedasticity, and we want the residual variances to be spread across those predicted fitted values. We want our residuals to be roughly equal across those fitted values. We don't want patterns in this case. And we can see here, we really don't have a pattern. We do have kind of a distribution here. They are kind of lumped towards the center, but they're still spread across those values. All right. And then last but not least, this last plot will give you an indication and be help you be able to speak to whether there are possible influential types of observations in your study here. And so you can use the residuals versus leverage plot here. And it has not only leverage to consider, but we also are considering Cook's distance. And so Cook's distance suggests that if we had removed one particular observation, how would the values or how would the outcome change? And so we don't want there to be a lot of change if we removed just one participant. Think about it. If we removed one case and there was a big difference, it suggests that that person is an outlier. It is an influential case, an influential observation, and we just don't want that. So we want everything to stay around or above that Cook's distance line that is plotted there. I know it's kind of difficult to see in this case, but it's this dotted line. And as long as everything is about on that dotted line or above, then we are good to go. Another thing that we want here is that we want to make sure that everything is hubbed around zero. Also, that we don't want really extreme values on leverage. I do want you to take a look at that scale on the x-axis. They're very tiny, so it may look like someone is very influential, but they're really not given the scale that the x-axis is actually on. So just being very mindful when doing something like that or evaluating this plot. One more time, we want observations to be around the Cook's distance or above the Cook's distance line there and not too far out, suggesting that a case or an observation could be influential on our outcome. Okay. So let's move on. I want to show you how you can go ahead and use Levene's test to evaluate the homogeneity of variance assumption. And so please go ahead and create a new R code chunk by using Option Command I there. Option Command I. I'm going to leave myself a note. Use the Levene's test for homogeneity of variance. Okay, so uniquely to ANCOVA, in this case, we need to make sure that we have the interaction present in that Levene's test. So I'm typing out Levene and then capital T-E-S-T for Levene's test, and then an open parenthesis. And then I want to first put the name of my dependent variable, and this is attitudes towards drugs, so DRUG, and then the tilde, and then I'm going to then specify my IVs, so religious stat. And then I'm going to note that I'm looking at the interaction. Employ stat. And I need to specify the data frame that I'm using here, and it is going to be ATT underscore capital DRUG. All right. All right, so now that we have this argument all set up here, I need to go ahead and run it. I can run it by being at the end or in the middle of my argument there, and then I'm going to hit Command and then Return, and then you'll get a Levene's test. I do want you to know that my Levene's test is significant here. It is significant here. I know this because my p-value is very tiny. You see those really those really bolded asterisks there. And so this is suggesting that the variance appears to differ across groups, which we will see later on. And so we are just going to proceed just to get through this example. But what I do want you to know is that you could address or deal with this difference in variance, right? By running a robust ANCOVA, which we don't touch here, but you could look further into it. All right. And then what we need to do after that is that we need to take a look at the relationships between our covariates and our outcome. I'm just going to implement and initiate a new R code chunk. I am, for the sake of time, just going to copy and paste that R code chunk that R code that I provided for you in the HTML file into my R Markdown by pasting it. I'm just going to change the name of my data frame here. And you don't have to do this if you went ahead and you ended up changing that data frame name earlier, okay? Mm. All right, thank you. And so you can just go ahead and run this. Let me make sure that I'm doing this right. All right. I need to run this all together. Make sure you're running everything all together real quick, okay? If not, you'll get that error that I just got. And it just sometimes jarring. I have to like reread it 5 times before I move on. All right. And so let's do this for every single one of our relationships or every single one of our covariates that we're going to be exploring right here with our dependent variable. You can see that I do have some sort of linear relationship. This relationship looks pretty flat and pretty weak, and that's okay. That's all right as long as it's linear. That's what we're most worried about is if we have a linear relationship, and you can see that we do. We don't have anything that looks like a curve among these plotted values amongst each other. All right, and so let me just fix this real quick. I ended up copying the code that I had used in the HTML file to evaluate the next covariate here. Okay. All right, and everything looks a-okay. One more time, please run both lines together. If not, you'll get that funky little error that I just got, and you'll be like, why did I get that? And so one more time, I'm looking at the relationship here between attitudes towards prescription drug use and then also physical health. And we can see that there is a linear relationship. One more time, this linear relationship does kind of look weak to me, doesn't look so strong because it's pretty flat here. However, it's still going in one direction only. And that's what I care about. Last but not least, I'm going to make sure that I take a look at not only physical health, but also looking at how the number of prescriptions relates to my attitude towards drugs. And I'm going to do this by using that plot function there, and then also noting where my variables are located at. That's what I'm currently doing by changing the code that I pasted from that HTML file. So I'm just going to go ahead and run these two lines one more time together. And then I can see that I do have a linear relationship. It's going in a positive direction. It's not crazy strong, but it is there. It's not as flat as the other two relationships that I went ahead and I evaluated up above. All right. So this is how we can look at the linearity. Last and definitely not the least, and the reason why I saved it for this very last part is because this is really important. Evaluating the homogeneity of regression slopes one more time will let us know if there are some sort of group differences that could be influencing my relationships here. And so we do have to end up modeling the interaction here between my religious status and my employment status and all other covariates okay? So let's do this. So I'm going to initiate a new R code chunk. I'm going to be using the LM function. I'm going to go ahead and use an open parenthesis. I'm going to type out my DV first. And then after I type out my DV, I'm going to use the tilde because I'm going to then list my independent variable first. And then that is going to be my religious status. And then what I'm going to do is I'm going to type out an asterisk and then another set of parentheses, and I'm going to list all of my covariates there. I'm going to list all my covariates, add a plus symbol between each and every single one of those there. All right. And then I'm going to do the exact same thing for my employment status. After I'm done with that parenthesis, I'm going to add a plus symbol. Then I'm going to type out the employment status name or variable name. And then I'm going to type out an asterisk there, a parenthesis, and within the parenthesis are going to go those same covariates. And I'm just going to copy and paste them for time's sake. All right. And then I am going to run this line of code. All right. Let's see. Oh, I forgot my data set name. I apologize. Don't forget your data set name. So after you're done listing all of those covariates in their parenthesis, comma, and then data equals, and then the data frame name, ATT underscore DRUG, and it automatically populates. I apologize, everyone, for missing that there and for not typing out my variables correctly. I think this is just like the one thing that I end up sometimes just slipping up on, which is totally normal. All right, and I'm assigning this equation here or this function to an object so that way I can then call it in later on. And I hope this finally works, and it does after I went ahead and I fixed all my little mistakes there. And then I'm going to go ahead, type out summary, and then enter, and then within there, type out slope, and then underscore model. And then I am going to do command and return, and then I am getting the summary of the model that I implemented here. One more time, what am I looking for? I am looking for any type of relationship, significant relationship that suggests that my covariate, right, the relationship between my covariate and my independent variable level is significant on the DV. Okay. We don't want that to be the case, right? We want, for instance, for there to be no type of interaction between our IV and our covariate, right? That we want all the slopes to be the same. And so I do note here that there appears to be a relationship between the number of prescriptions and religious status. And I'm just going to go ahead and take a look at it. I can see it here. And it looks like religious status, subscribing to a Jewish faith, and the number of prescriptions is much lower on attitudes towards drugs. And so I want you all to know that this is just suggesting that this slope could be different one more time. All right. When you have something like this, like to deal with something like this, where the slope is different. What we could do is that we could technically maintain the interaction, not interpret the main effects, and go to more of a stratified approach, meaning that we would go ahead and pull out all of the different populations that we believe are in our data set here and evaluate them on the dependent variable. You could technically run a moderation to keep that interaction going between the IV and those covariates, right? To maintain that. So you could do something of that sort. And so for the purpose of this example, we are just going to proceed. And so I am now finally going to show you how you can go ahead and implement an ANCOVA with a type 3 sums a square approach. All right, so how we are going to do this, starting on a new line, please go ahead and create a new R code chunk. And the first thing that we're going to do is that we are going to note that we are going to be using contrast because I am working with the type 3 approach here. And so we are going to specifically focus on using contrast sum, suggesting that our values here or our contrast here should sum up to zero, right? The on and the off, the negative one and the positive one, and everything else is all zeros. And so this is also known as CONTR dot sum for contrast sum. And then we also have our contrast poly that has to go in there, even though we don't have ordered categorical variables here, you still end up putting it in. But one more time, we're not using it, right? It's not going to help us in any way. And so we're just going to rely on the sums of the contrasts equaling to zero. So what you could do is that you could copy all of this code in this R code chunk, pasting it into your own, right? You don't want to change anything related to the options for those contrasts, but if you are using a different name for your data frame there, go ahead and change it, right? So for me, I'm going to change my data equals to, let's see, it's going to be ATT underscore drug for attitudes towards drugs. And so one more time, I'm implementing my contrast here. I want my contrast to sum up to zero. I'm not really worried about my contrast dot poly because I don't have a categorical variable or an ordered categorical variable in that sense. And then you can see on line 104, I have the ANOVA table, the ANCOVA table being generated by the ANOVA function, which we typically, what I show you normally is the summary function, right? I use summary and then I put in the model name. That is not what we're doing in this case. Please notice this difference here because this is how we can actually state that we are using a type 3 sums of square approach, okay? And so you could go ahead and run all this code by hitting that play button, or you could even do it line by line. It is up to you on what you would like to do here. Okay. And so I already have notes for you if you want to leave those notes there. Let's go into our table here. I want to show you what is coming up. My main concern, the thing that I am most interested in here is that interaction. And you can see that that interaction between religious status and employment status is not significant. Okay. Then moving on, I noticed that my covariates here, only the number of prescription is actually related towards the attitudes towards drugs, while all others are not related or they are approaching significance by that dot, meaning physical health is approaching significance as it could be related to attention to or attitudes towards drugs rather. But you can also see that my main effects are not significant. All right. And so I do want you to note that you would have to write this all up. Non-significant findings are findings. I hope you all know that. And so then you could first make sure when you're writing up that you note that you have evaluated your assumptions, how you went and evaluated those assumptions, and what were those findings of those assumptions in your results section. So, for instance, I definitely would write something like this. So, after adjusting for mental health, physical health, and the number of prescriptions, attitudes towards drugs did not significantly relate to religious affiliation. And you could even go on to doing employment status, or you can just go straight on to stating that there was no interaction between religious status and employment status and its relation to attention to drugs. If you do actually have an interaction, though, what you do need to list is that you need to list all the marginal means and you should explain those patterns. I do show you how to interpret marginal means in my mixed ANOVA design video, so you can go back and reference that there. If you want a write up where you actually have findings and you need a great example, please go ahead and pick up Tabachnik and Fidel's book there. It is fabulous. And if you want some more our support with statistics or vice versa, getting some R support for implementing some statistics, please visit Daniel Navarro's book down. It is fabulous. Hey everyone, thanks for joining me today. I hope that this video was useful. I'll see you next time.